showing me. How do I flip the camera? There we go.
Wait, how do I do it?
Perfect, there we go.
1 minute, guys. We're starting this YouTube live in 1 minute. So get your computers out, your phones, start asking your questions, and we'll see you in just about 60 seconds. Okay. 60 seconds. So you guys don't see this, but Frank is all masked up, and he's all masked up, and he's holding his cell phone camera at the edge of a long selfie stick here because we're social distancing. And so I'm just waiting to see how big Frank's arms are going to get in another month if he's still doing this. Well, I guess we're just about ready to start. Might as well just kick it off. Frank, you want to lead us in?
Yeah, let's go ahead. Welcome everybody to today's tip of the day, YouTube style. We've got Mark Terryberry here with his cup of coffee. He's ready to go. He's got his laptop powered up. And we've got Andrew, of course, with a proper desk today. And he's got his laptop. He's going to be scanning your comments and making sure that we're giving Mark some great stuff to talk about and keeping the show rolling. So, as we always ask, Mark, how are you feeling today? How's everything going in Terryberry Land?
I'm doing really good. Yeah, it's been a good week, quiet week. So I lived in the Midwest for a few years, doing machining, that type of thing. And right now, Southern California feels like the Midwest did to me, where I'm just going out a few times a week. My life has gotten a lot quieter. My wife is enjoying it. We're sitting around playing board games. And so it's been nice. So a lot of us at the factory are still doing assembly. We're still working. They've got all kinds of precautions in place. So the critical people are at the factory still making machines and shipping things. Some of us other folks who don't need to be there are working from home most of the time. I'm over here in a little photo area by myself some days, just running parts, writing scripts, that kind of thing. And then coming in on days like today where we're doing a live presentation and talking to you. And so we're doing pretty good.
Great. Andrew, let's go ahead and start.
Let's kick it off.
Yeah.
So we had a question come in from Chad Krause, and he asked, how do you align all your inserts so you get a really good mirror finish? We did have a couple good answers on that, but let's get your take on that.
You guys are asking like the toughest questions possible on these YouTube live type things or Instagram lives. And so go ahead and keep asking. Even if I don't have the answer, we'll give it our best shot. So align the inserts on a mill. So we've got different shell mills here up on the table. We talked about these before, and what they're talking about is basically the axial Z depth on these inserts. How do you, if one is standing prouder than the other one or one's too low, how would you adjust that to get things in? And the short answer is you don't. It's not as big of an issue as you might think. I would not spend a whole lot of time on that. I was watching some Netflix comedy show with John Mulaney a month ago, and he was talking about quicksand, how when he was a little kid, he thought that quicksand was going to be this really, really big deal. Like the biggest problems adults might face in life would be number one, dynamite, number two, anvils falling on your head, and number three, quicksand. But he went on to say that he never hears about the I-5 shutting down because of a patch of quicksand. Quicksand, because it's really not that big of a problem. In the same way, these newer mill bodies are made so well that they typically are just plug and play. You drop the inserts in and you run. With that said, the bigger the tool that you run, the slower the RPM. And if you've got one insert sticking up higher than the other one, it's going to show up and leave you a little swirly mark. If the whole thing was kind of muddy, it has nothing to do with an insert being high or low. It has to do with you've chosen the wrong face mill or you've chosen the wrong insert. So years ago, running automotive stuff, our guys would run great big giant face mills. And if we had an insert that was off, too low, we would actually use shim stock. Don't do this. It's again, quicksand. It's making things harder than they need to be. We would take shim stock and cut it up, sheets of it, like half thou shim stock, and place it behind an insert and bring that guy back up and going. That's not common with smaller face mills. If I've got a face mill that's not cutting well at aggressive feed rates, what I might do is go ahead and order up a box of wiper inserts. I'd put maybe one wiper in there, because the wiper inserts themselves usually stand up proud by a couple thousandths of an inch, 50 micron. And so you'll actually have one wiper insert that's going to be lower on the face mill than all the rest, but the land on it is so wide that as it sweeps around, it's the last thing to touch your part, and you get a nice finish. A mistake a lot of us made when we first started doing this, though, is buying a box of wiper inserts, and we have 8 inserts on a shell mill, and we make them all wipers, and then the finish is horrible, and we never use wipers again. That's a lot of axial pressure with all those wiper inserts, and it just doesn't work that great. So sometimes just singling out one wiper insert that's going to sit a little bit proud, and that's going to clean up your entire surface finish, and so that's kind of the best way to do it. Now on production runs, if I'm running PCD or CDN inserts, those are really, really expensive inserts, and so I might spend thousands of dollars, buy myself a cartridge type of face mill that has adjustable insert heights, the whole thing on your tool presetter, and you will adjust them in with the tool presetter or put them in the spindle, the 10th indicator, measure the height of each insert, and you can adjust those up and down with, each one's different, but a little tiny wrench and a jack screw. And that's especially important with expensive inserts that you are going to send out for regrind, like the PCD and the CDN. Those things are $100 an insert or whatever they are, and $8 each to regrind. And so Future Tech in Michigan, love them. They did a lot of regrinding for us. Those inserts are all different heights, and so you have to buy a mill body that is adjustable. And if you have one of those mill bodies, you're going to get all the inserts within 1/10 of a thou, within 3-4 micron, and you're going to get a nice surface finish. If you don't have an adjustable mill body, it becomes very difficult. These type of pressed carbide inserts, like for these guys, the ground ones are pretty accurate. They repeat really well. A lot of the press ones are only good within a thou or two anyhow. You're going to be chasing your tail. Really, all you can do is swap out inserts until you find the right match if you want to get things perfect. But generally speaking, you're much better off just not worrying about it. Find the right face mill with the right radius on the end, or go with a wiper. And again, don't load up your whole face mill body with wipers. Just try one at first, and see how that does for you. So again, you can stone a pocket if there's something really wrong with it, but that doesn't happen, right? Out of the box, these things are perfect for the most part. You can stone it, you can use shim stock. I would not do either one of those things while I have done both of those things. Basically, drop them in, see what happens. Otherwise, check your insert geometry and try a wiper.
Good answer.
Great answer.
I just want to say thank you for everyone that's showing up right now. We got over 180 people in the chat right now. Next up, we're going to go with a couple of people have asked you about the laptop that you've got there. So what kind of laptop is that, Mark?
I hate this laptop. This is the worst laptop on the planet. And not that Haas didn't give me a nice laptop. Haas bought me a brand new laptop a few years ago, and then they upgraded the hard drives to the SSDs, which like doubled the speed of my laptop. I had the old ones that spun, and now the new SSD laptop is very fast. The reason I don't like this laptop is because there's little scratches on it. And when I got my laptop brand new, I took very good care of it. And then when they upgraded the hard drives, we just swapped laptops one for another. And so the one that I just got in has a little scratch on it. I don't like it. So beyond that, this is just a regular Dell Precision. It's an M4800. It's an expensive laptop, but for a different reason than you might think. It's all about the video cards on laptops. So on computers, especially if you're doing a lot of cam work. If I was running CATIA or UG or something like that, the video card in this guy would be really, really nice. It's a Quadro, the NVIDIA Quadro K2100. And those are really good for the powerful cam systems. But on my personal laptop, I bought a Sager, S-A-G-E-R, which is all hardware, and it's got just a regular RTX 2070 video card in it. Not a 2070Q or M, the mobile version. I've got the real desktop video card in my personal laptop, and it kicks butt. It's awesome. So I've run benchmarks between my SolidWorks and other software, between the Quadro cards and my regular RTX 2070 or 2080 video cards. I don't see a lot of difference. So it depends on what cam system you are using, whether you've got to spend $3,000 on a killer laptop with a Quadro, or you can spend $2,000 for an amazing laptop that's good for games and everything else. And so there's a big debate about that, and it really comes down to the software that you're running on that computer, if it's going to even make use of the fancy video cards or not. So check with your cam supplier and ask them what their recommendation is for a video card, and then you build the system around the video card.
Oh, that's a good idea.
All right, so one of the ones coming in off the stream right now, RNS Machining and Welding asks, what's the best way to set tool and work offsets on a pre-NGC control? Still whips.
Yeah, well, okay, so you know that he's setting this up there. So let me run my toolbox. 6 foot,
Yeah.
dude. 6 foot.
That's right. Excuse me, let me get out of your way.
1 second. Don't look at my toolbox. It's a mess. It's a mess. It's like my rib. So what's the best way to set work and tool offsets on a pre-NGC? So we've made a couple of videos on it, and the comments were brutal. They just tore me to pieces because I'm showing you how to set tool and work offsets using a sheet of paper and other stuff like that. Now I've also got a, 1 second. This is my drawer, shim stock.
Shim drawer.
This is my shim drawer. So I've got all my different shim stocks in here with all the different stuff. I'll just grab one shim here. For me personally, 1 second, one more thing. Uh-oh. Don't leave. Where are you gonna go? One last thing. So what I've got in front of me are a couple different things. And we'd like to make a video on this, but there are just so many different ways to skin a cat. So I'm begging you in the comments, or send me an email at tod@haascnc.com. Tell me your best, most efficient way for setting tool and work offsets, not using the probe. Clearly, the best way to set tool and work offsets on a mill is using the probe. The same way, the best way to set tool and work offsets on a lathe is with the LTP or ATP, the lathe tool presetters, the automatic tool presetters. If you don't have a probe, you've got some other options. Some people will take a 1, 2, 3 block and a tool, and they'll touch off all their tools on top of the 1, 2, 3 block. They'll bring it down, and then they will slide the 1, 2, 3 block over, and then bring this thing up at a tenth at a time until finally the 1, 2, 3 block slides underneath it. They'll set that as their tool, and they'll set all their tools that way. Then they'll use one of those tools to set their work offset. I tend to, when touching off tools by hand, I tend to use a shim stock instead. For me, I get a little more feel to it. I can actually feel the drag a little bit better, so I'll use shim stock to touch off a tool. And of course, we've got, this is an old school digital touch off tool. And then we've got the newer styles of just regular gauges that have a gauge on, like this one from Edge Precision, where you can set all your tools on this single location and then move on. But more about how you touch off, it's about adjusting for the height of the tool presetter, whether it's 3 inch or 2 inch or 3 inch or 12 thousandths of an inch for shim stock, and how do you work all that into the machine. The issue with this is that if you do something very unique, something special to your shop, and you get a new machinist, they're going to totally mess up. So I tend to not like systems that require a lot of training. If it takes a lot of explanation, the way that you do things in your shop, then I tend not to like it. And I tend not to like methods that change settings on the machine, the way that we touch off tools. We've got setting 64, tool offset measure uses work. There's some things that we can do with that and create a system with that that take your work offset into account when touching off tools. It makes things easier. But now you change the machine, and everyone that walks up to that machine, you have to explain things to them about how you're touching off and whatever. Typically, when I write a program, I set my work offset at the top of my finished part. If I'm touching off my hands, and I let them touch off however they want to. But I realize that that's not the fastest way necessarily. And so let's do this. We'll write this down and make a real tip of the day topic out of it, and we'll put it on the list. And do me a favor again, send the way that you figured out is the best way, and I know you asked us a question, now we're asking the question back to you, but there's just so many different ways to do it. Send us what you've got, we'll make a video on it, we'll spend some time thinking about it, get the right combination of settings, software, hardware, and we'll come back and kind of spend some time and effort on this one because it's a great question. But again, whips is the best way. Probing.
That's something we've done a lot of work on, so it's going to take us a while just to discuss what we're trying to say with this next video when we do it. And by the way, RS Machining and Welding says that he's currently using the shim stock method. All right, so moving on. Jazz GT says, greetings from Guatemala. Any tips on setting up a fourth axis for the first time?
Oh, a lot of those questions. Okay, ask the question.
It's funny. What's funny about that question is the exact same question.
It's scary to get started a little bit, right? It's different. This rotating thing is a little bit different than what you're used to.
It comes down to if you have a probe or not. So if you the easiest way to do it is you bolt on your part, you touch up you have to find the center line of the rotary, right? Once you've found the center line of the rotary, one way and the other, you're almost all set. Then you have to decide if you are working on some type of blocky part where you can touch up on top of the part, you just set your work offset like normal. And then when that thing flips over, you set a different work offset. So this is G54, set your work offset, machine it, just like a 3-axis mill. Then when the thing rotates over at 90 degrees, that A 90 degrees in your code, then you just set a G55 work offset and do all the machining there. That is basic. Absolutely no different than a standard 3-axis mill. If you're doing something that has full 3D shape, and you're doing 3-axis here and here and here, oftentimes what we used to do is program everything off the center line of the tool. So if you have a rotary, and the center of the rotary is here, then instead of setting your work offset at the top of the part, you set it at the center of the rotary fixture. So no matter how it flips around, your 0 is always in the same spot. And then of course, beyond that, what we have on all the newer controls is dynamic work offset, tool center point control, where the machine, I'm looking at a UMC over there, you can't see it, where the machine already knows where the center line of rotation is, the MRZP, machine rotary 0 position, and it makes programming so much easier. And I know we've gotten a lot of questions on that lately, and Andrew and I have been talking about that, and we're making another video on that, exactly how to program using tool center point control. We had a short video on that, but we're going to go more in depth, and exactly how to program using dynamic work offsets, a couple different ways to approach that. So we'll be hitting that topic again. It's kind of an in-depth topic again, that we want to spend some real effort on. But there's lots of ways to skin a cat. Again, you can, top of the part or center line of rotation, or like the UMC or the newer machines using dynamic work offsets and tool center point controls, where the machine does all the heavy lifting for you because it knows where the center line of rotation is, and it does all the math for you when it rotates. But we'll cover that topic again because it's kind of deep.
Yeah. Let's jump over to this is a question that came in the last couple of days. Machine 27 asked if we could make a stem to stern video on the mini mill, kind of a cradle to grave kind of thing. We might do that, but he also had questions. The first one is the mini mill a linear rail machine? And the answer is yes. All 3 axes use linear rails. And the second question is, with the Z all the way down, how tall is the machine? Wondering if it will fit under a 7-foot residential garage door, or 84 inches, I'm assuming. If you go to the website and you click on the mini mill page, you navigate to the mini mill page. On the main page there, you'll see a tab that says layout drawing, and if you click on that, it gives you dimensions for the overall machine. But included in that, on most of the layout drawings, may I say all of them, there's dimensions for the minimum height that you can get the machine down in terms of fitting it into a workspace. And in the case of the mini mill, the number that's quoted on there is 79 inches. That's with Z-axis all the way down in its shipped state, and the regen box and the cable carrier that loops over the top of the machine, both of those pulled off. And actually I went down to this is what we typically do if we have a customer that needs a machine and they're trying to get it into a really tight space. We go to that layout drawing first, but then almost always we run down the factory floor, just double check, make sure everything looks like it's gonna make it through a particular space. In this case, I measured this morning, it was about 78.5 inches of clearance. So that still means, maybe you've got 4 or 5 inches you're probably going to want to work with your HFO salesperson. Maybe have them come and look at your particular location and actually measure the exact size of the space and decide on what the riggers are going to do. Because in terms of whether they rolled in on skates or they want to bring it in on a forklift, that's going to determine whether it really fits or not. But it looks like it should fit.
Awesome.
Yeah, so that I think hopefully answers that to some extent. Next up, we've got another question from the stream here. Bikramajit Singh asks, please teach us about macro programming.
Oh, yeah.
It's something near and dear to Mark's heart.
This stream just got to 3 or 4 hours long.
Yeah, that's right.
Macros are awesome.
That's great.
We should do like a macro tip every day.
Hey, what about that? What about a macro tip of the day series? That's not something we've talked about 50 times.
It's one of your favorite topics, honestly.
I love macros.
Yeah.
So I use macros all the time. So right now we were doing a video on some other thing that we were talking about, feed rates on arcs. Actually, it was based on a question that came in a couple weeks ago. And so I have a part in front of me that I was running yesterday, and I wanted to see how long it took, exactly how long it took from here to there, and then from here to there. So I put a millisecond timer on my program, and so I just use it constantly. I said pound 3001 equals 0. Pound 3001 is our timer. I set it to 0, and before I did that, I put a /. So / pound 3001 equals 0. Set my timer to 0, and then I ran all my junk. And then at the end of it, I wrote pound 100 equals pound, and I put a / so it blocks look ahead. We made a video on blocking look ahead. / pound 100 equals pound 3001 divided by 1000. It's a millisecond timer. I want it in seconds, not milliseconds. So then I could compare all my cycle times. And so I used it all the time. And that told me that the one cycle was 4.28 seconds, the other cycle was 4.35 seconds, and I could do my testing. So from a testing standpoint, I use it constantly, but it's also great for setting work offsets and everything else. We'll do more and more about it, but for now, what we can do is I will give you a list of a half a dozen different macro videos, or rather a half a dozen different videos that we've already done that have macros wrapped up into them. And I bet you, if you watch those, those few videos, you will have a pretty darn good grip on how macros work on the Haas control. But we're going to continue to do them for sure. So I'm going to leave myself a note, and once this video is all posted, then I'm going to give you links to a bunch of different videos we've done that include macros that will really help you kind of get better at macro programming.
So we've been hovering up around 175 to 200 viewers, and we really appreciate it. YouTube, thank you so much. A couple comments about folks liking the widescreen format versus the Instagram look. So appreciate that.
Yeah, thank you so much, everyone. We've got people coming in from all over the world, of course. Let's go next with Super AWAC and Tommy Honkanen both ask, well, I'll read Super AWAC's question. Any plans on adding mill turn capability to the UMC series or any machine with a built-in rotary axis like the new horizontal? I would buy one yesterday, no questions asked. And the answer to that, I'm going to just give an extremely brief one, is we're working on it. It's something that is in engineering right now, in development. Mark and I were talking a little bit about software development for such a machine that was set up in the past. It sounds like plans have been in place for some time to make that a doable thing.
So if you guys haven't seen it, check it out online. It's kind of cool. We have this GM2 5-axis, right? It's a tilting head machine and that kind of stuff. And what is unique about that machine is they could have gone through and created different CAN cycles, all the 5-axis CAN cycles for each face presentation. They didn't do that. When they wrote the software, they took the hard route and they created tilted working planes. These different work planes so that your G81 drilling cycle will work at any angle. You just put in the angle, and they made it super easy. So they spent an awful lot of time getting the software right for that machine, and they're continuing to develop that. Now, what that means is that whenever they decide to, and engineering they're prototyping stuff all the time. But whenever they want to, we've already have the software codes already built for mill turns already. So at this point, it's just whatever they think the customers want. So if you guys want a mill turn and you're ready to write a check, then tell your salesman. maybe that'll push the development. But again, they've got they've got weird Frankenstein machines in the R&D lab all the time that are cutting stuff and just trying to see what the next useful machine might be.
We've got a question here from Nerdly, or maybe more of a statement.
Who's that?
If you are familiar with Nerdly, he's saying it'd be cool to have a technology video that focuses on globoidal versus cycloidal versus direct drive and worm drive.
I love that.
That's a real like basics kind of engineering thing. That'd be pretty neat.
You guys, we don't have the video on it, but that's what he's talking about there. Go to Google or YouTube and just Google cycloidal, cycloidal, cycloidal rotary. It's insane. It makes no sense at all. It's this weird loopy motion with a smaller gear inside of a bigger gear. And so that's the way a lot of our rotaries function. And so we've got different types of rotaries. We've got kind of direct drive worm gear styles, which are incredible. We have worm gears that are, the nice thing about that, as far as the rotary goes, is that you can put tons of torque on the rotary itself, and it's not going to move. You can put the brake on also, but just the worm gear itself can't be driven backwards, which just makes it ideal for machining on stuff, especially full fourth and fifth axis. It's a very robust system. And then you've got the ones that have the cam bearings in them, the cycloidals, the same thing, but we run those faster on some of our faster rotaries. And then some of the new machines like the UMC 750 or the 1000, a lot of those, and some of the small ones too, are running those new cycloidals. But it's just, I can't even begin to explain how those things work. It's like science fiction. So it's fun to watch. But it would be cool to make the video.
It's easy to understand. But the worm shaft and the gear in it, they move like this, and you see this one rotate, and you see this one rotate. It makes perfect sense.
But I would
I
lose a million brain cells just trying to think about how the cycloidals work. So Google it. But that would be an awesome video. It would definitely need some animations. But that would be a fun one.
Yeah. Let's come back to a question we got, I think it was last week, from Aero Method. What can I do to prevent my coolant from foaming? I'm running at 12K all day long. And yeah, we talked a little bit about this. One of the things that we say in all our coolant videos is that you really want to pay attention to your coolant mixture. And if you were running, let's say you were running a bunch of tapping jobs and you bumped your coolant ratio up to say 10% because you wanted that extra lubricity, you often are going to see more foaming there. But then a lot of it has to do with the coolant type itself. What we found in the factory is that a semi-synthetic, we use Castrol coolants, but a semi-synthetic coolant has given us the best of all worlds in terms of not rusting the parts, lubricity in the cut, and not foaming, and also resistance to bacteria. But then Mark had some other comments about the trials and tribulations we've gone through.
Every comment that I've got as far as foamy coolant should be completely ignored. I clearly do not know what I am doing. So years ago in a small job shop, I had that problem, right? You're running parts all night long, pallet changer, this type of thing. You come in the morning and it's like somebody poured in, a gallon of detergent into the washing machine and the whole house is foamed up. So you walk into the shop and you've got foam everywhere. How does this happen? And I don't know what causes that. So I remember at the time immediately going down, do not do this. Going down to the jacuzzi store, the pool supply warehouse, and buying the anti-foam stuff. And that stuff's terrible because it's got silicone in it. And then we'll go down to the carpet cleaner place and buy the anti-foam stuff for the carpet cleaner and dump that in. And now I'm sure your coolant's ruined. You've added all this weird chemical stuff to it. And some of the high-end coolant guys will come in and they'll add like a calcium acetate. They say that it foams up because of low calcium in the water. There's all kinds of reasons, but it kind of comes down to what coolant you are using. And almost every coolant brand has some type of anti-foam agent that they will sell you to help slow down that process. But again, there are things you can do to your coolant that ruin it. And you're going to end up emptying out the tank and starting from scratch with the right coolant concentration, the right pH, and those type of things. So I'm sorry I don't have a great answer for you. I'll talk to the coolant guys, and it might be worth, if there's some simple answers, we'll convey them back to you. But I just know that I've had bad luck fixing it easily.
It's very much the same kind of problem we run into when you have bacterial contamination. people get a bunch of bacteria in their tank and they start freaking out. It smells bad, and then they go to the pool supply store. They go somewhere and they buy some crazy aggressive bacterial killing liquid, and they drop it in there, and maybe it kills the bacteria, but they end up just ruining the coolant. And you can easily kill the lubricating and cooling properties of the coolant. So it's a slippery slope. Anyhow.
So lots of comments about people just saying thanks for being awesome and for making all these videos and for taking the time to do live streams. I can tell you as a behind the camera guy, we never get tired of hearing people say thanks, and we appreciate your comments so much.
Thanks for saying thanks, and thanks for being on here. It looks like we were interested to see what the stream is going to be like compared to the Instagram live thing, and we think that this is probably going to be a better platform in terms of longevity of the video and being able to answer more questions and seeing the history of the questions after we do this, and hopefully answer some of the ones we don't get to today, next week and the following weeks. Here's another one from last week, I believe. Montoya Adventures asks, why so much blue rust preventative? And I mean, yeah, the blue stuff is not the funnest to work with, that's for sure. But it does keep the machine rust free until it gets to the shop, and that's the main idea.
Oh, Orville made a video on that, but I don't know if it's public. So we make lots of videos for our own service guys and that kind of stuff. So Orville made a video on that was awesome. I don't know if it's public. I'll find out. But what he did in that video is when the machine first came in, you absolutely, if you get a brand new Haas machine with the blue stuff on it, grab yourself a 4-inch plastic scraper and scrape it all off. Do not start wiping it off. You will never ever get to the bottom of it. It's like it's incredible.
Like 10 packs of towels.
Oh yeah. So you want to scrape off the blue stuff first, but there's a really good reason why we use the blue stuff. It's because when we ship machines overseas, that boat might take 3 weeks, and it doesn't take long at all for iron to get moisture from the air. Now, when we ship a machine, we have the desiccant things that we ship with it, so we keep the humidity real low by putting all these buckets of desiccant in there that suck the moisture out. But even with that, you might get some rust on some surfaces if they're not coated. In years past, we would coat them with really good RP, rust preventative. But if you missed a spot in the sprayer, it would rust on that spot. No one wants a rusty machine. So they switched to the blue stuff because it's more for our benefit when we're applying it. When you spray it on, you can see a mile away if you've gotten every square inch of where you need to cover. And so if it's not covered with blue, it's not protected. And so we just have to do it. We'd much rather spend an hour cleaning up the blue stuff than end up with a brand new machine that's got some rust on it. But again, it's a really waxy type stuff. Scrape it all off first. And then once you've scraped it all off completely, go through a real quick wipe up, and it shouldn't be that big of a deal. Just don't start wiping right after that.
Yeah, it's very much about using the right process to remove it. It was the same with SP400 or Cosmoline, and 5 or 10 years ago. I remember going on some machine installations when I was back writing work instructions and stuff, and like the key to getting SP400 or Cosmoline off a machine was WD-40. You could work all day long with anything else and nothing would cut that stuff correctly. As soon as you spray with WD-40, wipe right off, and you're good to go. And of course, the techs who are installing the machine know that. So it's just knowing the right way to do it. Let's go back to one of the ones from the stream. JFlight16 asks, thoughts on using Through Tool Air Blast to clear chips?
Oh gosh,
It's great, right?
oh, it's fantastic. So if you're running a shallow part, if you never go more than a ½ inch or an inch deep with your tools, no matter what you're making, there's no reason to buy TSC and there's no reason to buy tab, the Through Tool Air Blast. With that said, I've said this 100 times and I'll say it every day because I'm the button pusher, I'm the machinist, not the owner of the shop, but I run the machines. If I'm doing anything deeper than that, more than a 3 or 4 to 1 ratio on the tool length, anything deeper than that, please, if you are thinking about buying a machine, for the sake of your machinist, buy TSC and tab, because it just makes my life easier. That's all I'm saying. If I'm in a deep pocket and I'm running a TI-ALN cutter on some mold base, and I want to get the chips out of there, but I'm not running coolant, I'm just roughing things through, then you will definitely want to run TAB, the Through Tool Air Blast. It's fantastic for getting all the chips out of there fast. In the same way, if you're running anything deep, TSC or through spindle coolant will just get you out of a pinch. You cannot fake through spindle coolant on a deep hole drill. And so the same thing, you can't get the chips out of a tight pocket without TSC or TAB in nearly the same way with just flood coolant. There's just no other way around it. And so we'll cheat sometimes. So we'll run the air cylinder on here. So like an M2L system, I like this. This will actually work pretty darn good for shallow pockets. I like this guy a lot. And so that'll blow chips apart pretty well. But in the same way that this is flood coolant, through spindle air is like through, like TSC through spindle coolant, and it just allows me to run much deeper and much faster. And your tools are going to last longer because it's getting the chips out of the way, or it's getting the coolant right where it needs to, right on the tip of the tool. So it's just a neat benefit, and I would just buy it. I mean, if you possibly can, buy it.
Same as TSC, right?
Yeah, same thing as TSC.
Yeah, TSC and whips.
The only reason you're using tab is if you're running, some steels that can run dry inserts. And again, the TIALN, some of the other stuff, some of the inserts actually prefer running dry as opposed to with the coolant to avoid thermal shock on those inserts. And so that's why you might want tab as opposed to TSC or in addition to.
All right, let's just ask the question. I mark CNC. I don't want to get you into a pickle here. Not a pickle, but anyway. I mark CNC asks, can you explain G187, E1, 2, and 3, and how to set it in parameters?
Yes, I can.
Can we do it right now?
No, I can.
Minutes?
So what we're going to do is I'm going to go here, and we will go to YouTube. I'm going to go to Haas tip of the day. I'm going to search here. I'm going to type in G187. And so I've got this video here. We actually got a couple of videos left. So we've got a nice one here from Autodesk, and we've got this other one here, which is one that was a TOD. So this video right here, G187 for better surface finish and faster cycle times. This video shows the use of these different cycles, the P1, P2, P3, and let me see if I can pull through it. As we're fast forwarding, you can see the difference in surface finish with these cycles. Trying to find a good cutting footage here. But you get the idea. You could have already gone there yourself and ran through it. These cycles are amazing when it comes to running 3D surface parts, especially. So I'm not finding the space that I want. But anyhow, you get the idea. So just go to YouTube. We think you know how to get to YouTube. I know you do, because you're watching a YouTube live feed right now. When this guy just type in G187. We've done a complete video on that topic.
And we can go into the comments and add the URL for the video.
We'll add the URL as well.
Make a note.
Just a quick shout out to all the people that are still here on the stream. Thank you guys. We've got people coming in from India, the UK, South Africa, Pakistan, Italy, Mexico, Saudi Arabia, Guatemala, and Turkey, just to name a few of them.
The stream's going strong. Right?
Yeah, it's going really strong. Almost 200 right now. This is a question from several weeks ago. A nice open-ended one again. AC9100 asks, how do you mitigate vibration from surrounding machines in your workstation?
Oh, wow.
Oh, man. Social distancing. Social distancing is the answer. 6 feet between machines. Make sure your machine is wearing a mask, and that'll take care of all your problems. We have the problem at different customers who might complain about an issue with their machine, and then we send out a tech second, third time, and then they come there at just the right time when the giant freight train on the tracks 50 feet behind their building rolls by. And then they put an indicator on the floor, and you see that the entire floor is bouncing by 10,000ths of an inch. This is a real problem. I've ran big machines in big automotive factories and fought with surface finish issues and fought with some chatter issues before realizing that what I thought was a fantastic foundation, right? We had 9 inches of reinforced concrete, but the machine that I was running needed 4 foot of reinforced concrete. So we had no choice but on that particular machine to cut a giant hole in the floor, drop in 4 foot of concrete, isolate it from the rest of the concrete shop floor, and then all of a sudden all my problems went away. In that particular case, we had what was called a Broderson. It's a giant forklift crane thing that would load our fixtures. It would drive around the shop. And I didn't realize it, but every time I had a bad part, it's when that forklift would drive by, the Broderson. And every time he would drive by, my part would be bad surface finish on a block deck. And I just happened to be there at the right time with an indicator on a part when that thing drove by, and my indicator bounced all over the place. It's really hard to isolate those kind of problems. If you've got a vibrator, you don't mount it next to your mini mill, right? You put it out in the yard, and you build a fence around it with some soundproofing so you don't have to hear the thing. But it's a real tough issue. There's no real good answer for it. On a lot of Haas machines now, we're using foundation bolt down kits, and so you'll actually clamp down the footing on some of the machines to the concrete, which is going to make the machine a little more stable. Can't hurt unless your concrete is thin and you've got forklifts driving by and you're basically rocking the entire machine. There's not a really great method to do that other than cutting the concrete, isolating the pad. On a simple thing, you can do that. You can cut the concrete, isolate the pad. Another option is, if you're having that kind of problem, is to make sure that your machines are set on a single slab, that you're not splitting the line. So if you've got a seam like we do here, best case scenario is to place the machine all on one pad. Don't split it, because that's when things get really bad, is if you've got a seam and then a forklift drives by, your machine is literally rocking on the pad. But so much of it has to come down to the foundation, where the machine is sitting. If you're on the second floor of a building on a wooden floor, yeah, you're gonna have problems.
Yeah, Jason Neal right here, just a few moments ago. Previous place I worked at in tool and die area, there were always issues with surface grinders and wire EDM when the 200 and 300 ton transfer presses ran in the department next to the area. Yeah, I remember working as a welder years and years ago, and we had a welding area, and then we had the Amada punch press about 100 feet away, and you'd be welding along, TIG welding, where you're really trying to be accurate and have a nice finish, and that thing would start hammering away, and you're just like this. Luckily, we weren't doing any machining near it, but it would have been a nightmare. Now, this is another question from one of the YouTube comments. Jason Oakes, this is a long one, so bear with us. Jason Oakes of Oakes Manufacturing has this to say. I'm finally getting up and going on my spanking new UMC 500. I use tool diameter cutter compensation. My cam system outputs peripheral feed rate adjustments automatically on internal radii. There's a few other parts of this, but then he asks, is it better to turn setting 44 to 100% and have my cam software adjust the peripheral feed rate on internal radii? Or is it better to leave setting 44 at 35 or 50% and have my cam software not adjust peripheral feed rates? This is very much in the weeds, isn't it?
So it's funny. So he just read this comment offline. I've spoken with Jason via email. So we answer questions, and when I get questions that are too hard for me, I kick them over the fence to the applications or service departments. So I've got a get out of jail free card. Unfortunately, when they get a problem that's hard, they have no choice but to answer it. For me, I've got somebody I can ask. So on this particular question, it opens up an entire side of machining that lots of us have never thought about. Now, Jason is brilliant. He's really thought things through. And a lot of us who are machinists sit in front of a machine all day long, and we think about this stuff until we become PhDs in machining. We've thought about stuff that no one in their right mind should ever think about. What Jason is talking about here is that, and we're going to make a video on this, I think. It's worth talking about. But if you, it's funny. So I was doing machining on this the other day. This is, so he has this question because of the comment online. I was machining this for a similar reason. This is a thread mill cycle. I'm just going to grab a thread mill and then we can go back to the farm. So this guy's a thread mill. I might as well show it right there. And so this thread mill, it's kind of long, but that's where the welding flat is. This is the tool I've got. If I was going to thread mill this thing, which I did, and this is a very small hole, about 3/4 of an inch, and my thread mill's about 5/8 of an inch, something like that. If it comes in and then interpolates a circle, what he's talking about is most of our cam systems spit out a feed rate, but that feed rate is based on the center line of the tool. We talked about this briefly last week, and so our feed rates get get amplified because your feed rate really shouldn't be at the center of the tool. It's really at the outside edge of the tool. So when this comes in, we're like, oh, 10 inches a minute, but it's really going 100 inches a minute at the outside edge where it's making the contact. And if you've ever taken an end mill and machined a small bore, you come across this problem where it just sounds horrendous. You thought 50 inches a minute was fine, and it was. You run 50 inches a minute all day long. But now you put an end mill near the size of the hole, and you run that same 50 inches a minute, and you're going basically the max feed rate of the machine. So how do you compensate for this? The cam systems have it built in where they can decrease the feed rate in arcs, and so a lot of them have that. And so check with your cam supplier to see if that's an option for you. But if you're someone who is programming by hand, or you're entering your tool diameters, if you're entering your tool diameters by hand on the offset page, 0.625 or 18 millimeters, wherever you're adding in on the offset page, if the machine knows what your diameter is, it's already compensating for this type of thing. So if you're using cutter compensation and you've entered a tool diameter onto the work offset page, onto the tool offset page, it knows how big your tool is and what the difference is between your finished part and the tool path, and it slows down your tool for you automatically, all in the control software. And setting 44 is what controls that. By default, it's set to 50%. It's saying slow down my feed rate as much as 50%, which means if I programmed 100 inches a minute, it would slow it down to as much as 50 inches a minute. Now, if that's not slow enough for you, you can lower that setting 44 value to 1%, 10%. If you slow it down to 10%, then if you're going 100 inches a minute, then it could slow it down to as little as 10 inches a minute, so you get the correct effective feed rate where the rubber meets the road on the outside of the part. And again, I think it's a good topic. It's really complicated, but it's good to be aware of. Generally speaking, if you're having that problem and you're coming in with a end mill about the same size as the hole, and it goes, just slow down your feed rate. Instead of going 25 inches a minute, go 2.5 inches a minute. Just as a general rule of thumb, knock your feed rate down by 90% if you're getting that small. If you're trying to create a 3.5 millimeter hole with a 3 millimeter end mill, just slow your feed rate way down to nothing. But there's so much to that topic. We should probably give it another a TOD at some point. But just realize there are cases when your feed rate's not your correct feed rate, because generally speaking, the machine is running your feed rates off the center of the tool, not the edge of the tool, unless you're using cutter compensation with a tool diameter on your offset page, and in that case, it's going off setting 44, and it's making some adjustments behind the scenes.
So we had someone make a comment about the speed of the tool change. That they had a non-super speed machine.
Oh.
And that it was like striking on the video.
Oh, this kills me. I hate this. We'll go to customers, and the first thing they'll say to me is, "Can you slow down the tool changer?" Why would you want to slow down the tool changer? They say it's too fast and it can't be good for the tools. And we're like, it's fine. Excuse me. It's fine. There's nothing wrong with the tool changer running that fast. It's totally happy. The only time we'll ever slow down the tool changer is if you've got a great big giant tool. And in that case, we'll want to slow it down. And the way we'll slow that down is by designating that tool as large or heavy on the tool offset page. So we've made videos on that. Just Google large heavy tool on the Haas YouTube page, and we'll explain that. We also made a video on the right angled heads, and those big giant heavy right angled heads where the drill bits or the end mills coming out the side. And in those cases, sometimes the pocket up-down switch on the side of the machine is going up and down too fast. And so all we do is we put in a tiny little air regulator on that air line that goes to the pneumatics for the up and down. We can slow that down for you as well. So there's a little piece of hardware that we can buy to slow that down if you're running a huge heavy tool. But for the most part, just let it rip. Just let that thing go, and it'll be just fine. It's fine with your probe. We run probes every day at full tool change speeds. Doesn't hurt it at all. The only time you'd want to slow that sucker down is if the tool is really large, really heavy, and so you set it as large or heavy on the page, and you'll be just fine.
Great comment.
All right, guys. I think we're gonna wrap it up. We're at looks like about 48 minutes. As always, this goes. It feels like about 10 minutes that we've been talking, but we're almost at 50 minutes. We're well over 200 people on the stream. Thank you very much, everyone, for joining us today. There's a ton of questions that we didn't get to. We'll try to throw some of those into the mix next time. And it looks like YouTube's gonna work pretty good, I think.
Yeah, we love the
Thank you
platform.
everyone so much.
Thanks so much, everybody, and thanks to Mark for answering all our questions. Thanks to the audience.
Oh, don't forget, I really, now that you've brought this subject up, come back to me with this idea. I know that there's a bunch of H-Tech, machining teachers out there that teach us every day, that have what they think is the best method in the world for touching off tools manually, the best system. I've got my best system, but again, 100 different ways to skin a cat. Email me at tod@haascnc.com. Let me know how you're touching off your tools manually. If you've got some perfect system, we'll kind of go over them here, and we'll make a video kind of feeding back some best practices. That's it. I guess we'll see you next week.
Thanks, everybody. See you next time on YouTube.